discussed that whenever you have a number multiplied by a number multiplied by a number quite a number of times, let me describe it. If you combine to pass and back, there's one bit there. Okay. All right. So we saw that if I say A to power B, A to power N, what does it mean? A to power N, it means that I multiply A N times. Okay? That's what we saw. If I take a number and then I raise to a certain natural integer, it's just taking this number and multiply by itself 10 times. Yes? Okay? So, for instance, if I take 4 to the power 5, it's just 5 to 4 times 4 times 4 times 4, 5 times. Okay? Alright. And that's what we call exponent. Okay? Yeah. So, we learn how to, if I give you a number now, you could try to write it in a form of exponent. If I give you 64, you could try to write the decomposition. And if you want to do the decomposition, you need to first find the common divisor. So you first start by dividing by 2 or 3. What are the divisor of 64? And you can notice that the divisor of 64 is 2. Divide 64 by 2, what will you get? So if I want to do the decomposition, this is how we do. I first do divide by 2. 64 divided by 2 is what? 32. I divide by 2. 32 divided by 2. 16 divided by 2. Divide by 2. Divide by 2. Divide by 2. 1. And then we stop there. So how many 2 do I have? 1, 2, 3, 4, 5, 6. So actually 64 is what? 2 times 6 and 2 to the power 6. You understand? So if I give you another number now, and I ask you to write it in the exponent form, I give you 81. Write it in exponent form. You can do it, right? 81. Yeah? Yeah, 81. And there's what? 3 to the power 4. Yeah? So you do what I did, and then you write the exponent. Okay? Right. So that's the basic things. Okay? Now, since we saw about exponents, it's good to already look at the different way of evaluate the square root. Roots. I mean roots. Yeah? Because if I say root, there are different types of roots. It could be square root, it could be cubic root, it could be another type of root. Okay? So let me say roots. Okay? So the first type of root is what we call square root. Right? So we know that it's like this. It's called square root. Okay? And this square root is applied to a positive number. Okay? So suppose that I have a number, a perfect square. If I have a square, where a is a positive number, if I do the square root, it will give me a. Where a is positive. For instance, if I want to evaluate the square root of 2 to the power 6, if I want to evaluate the square root from an exponent power, what I need to look at, I need to look at the exponent. And take the number raised to the power, the exponent divided by 2. What I'm saying is that if I want to evaluate the square root of a to the power n, right? I have to check what is n. The n has to be an even number. Eh? The n has to be an even number. Okay? So if n is even number, what we call even number is a number that is divided by 2, right? So if n is even number, then my square root will be a to power n divided by 2. That's what I mean. No. If you get order, that's another story. That's another story. So that I started by saying that we actually evaluate the square root, eh? Perfect root. But this n has to be even. Don't write another thing. Eh? Okay, so here, what I'm saying here is that n has to be even. That's very important. Okay? For instance, if I want to evaluate the square root of 64, but we know that 64 is actually 2 to the power 6, right? What is 6? Huh? Is it a whole number? It is 6. Who is saying 6 is a whole number? Raise your hand. Raise your hand if 6 is a whole number. Nobody. Okay? So, what will be the answer? 2 to the power 6 divided by 2. What's the answer? 2 to the power 3. So the answer is what? 8. Square root of 64 is 8. I evaluate. Okay? You understand? So evaluating the square root, just be careful. You see, my square root, the way that I wrote, is called square root for a perfect square. Is when the exponent is even. When the exponent is even. If I ask you now the square root of 9 squared, square root of 9 squared, 2 is even. Is even. 2 is even. So the answer will be 9 raised to the power 2 divided by 2, which is 1. So it's 9 to the power 1. You understand? So if I say square root of 11 to the power 5, what will be the answer? What will be the answer? What will be the answer? Switch off the phone. Class? Is it class? You don't know the don't enter your phone. What is reading? Okay. What's the answer of this one? What's the answer? 11 to the power 5. 5 is odd number, so we cannot apply what I'm saying. Because 5 is odd. What I'm saying is that only apply when there's only this even. Okay. So now, let's look at another case. Another case. It's called cubic. Cubic root. It's called cubic root. Cubic root, or really cubic root. The first that we saw, square root, and this is the right hand, and what I want to. So that's how this is what we write. The 3 is somewhere here. 3 is somewhere here. Okay? Okay? So how do we evaluate the cube root of a number? Of course, you evaluate the cube root of an exponent number. If you cannot write the number in exponential form, that will be difficult to evaluate the cube root. Okay? So first of all, if you want to evaluate the cube root or maybe square root, you first need to write it in exponent form. That will be easy to transform. Okay? And for this one, if you want to evaluate the cube root of a, this is 8 power n. This is 8 power n. we are saying it is different situation. We already deal with the first case. The second case is when I'm actually evaluating the cube root, where n has to be what? A multiple of 3. Remember, for the first case, n has to be a multiple of 2, which is even number. But the second case, the n has to be a multiple of what? 3. Okay? So, if I tell you to evaluate the cube root of 2 to the power 3, so this is actually, the answer is a to the power n divided by 3. N is where n is multiple of 3. Okay? Okay, so cubic root of 2 to the power 3 is what? 2 to the power 3 divided by 3, which is what? 2 to the power 1, which is 2. You see, it's very simple, huh? It's very simple, eh? Very, very simple. You see, explain again. Okay, so you, here, this is, we are dealing with cube roots, okay? Cube roots. And you want to evaluate the cube root for exponent number, okay? But the exponent has to be a multiple of 3. If it is not a multiple of 3, you cannot apply the cube root. Okay? So just check whenever you want to evaluate the cube root, you have to check first the exponent. That's the first thing. You need to first check the exponent. So if you check the exponent and then you find out that the exponent is a multiple, you know what's the multiple of 3? What's the multiple of 3? Give me an example of multiple of 3. 6. Another example. 9. Another example. Okay. Yeah. So just to, but now the example I'm giving it, this 3 here is not here. I put it here. Don't make a confusion. It's not here, but it's here. Okay? So I just apply the formula 2, 3 divided by 3, 2 to the power 1. Okay? Yeah? So if I want to evaluate the cubic root of 5 to the power 6. 5 to the power 6 is what? Is what? Yeah? 5 to the power 2, 5 squared. Yeah? Yeah? But if I say, what's the square root of 5 to the power 6? Is 5 to the power 3. Right? So cube root and square root, they are different, eh? And you understand? Huh? Okay, good. So that's how you evaluate the cube root and so on. So okay. So let's try one example. Let's try one example. Any question? So let's try to evaluate. You want to evaluate the square root of 2 to the power 6 multiplied by 3 to the power 4 multiplied by 5 squared. Okay? That's what we want to evaluate. Yeah? Are you following what you are not even in the class, eh? What's the answer? What's the answer? Who is not in the class? And who is not in the class? Who is present in the class and then is outside? And your body is here, but you are somewhere. It's better to be outside with your body than Okay, so that's what we want to evaluate there. What would be the answer? Are you seeing over there? Ah, you're not seeing it. Maybe I will put it at the back. It's much better now. Okay, it's much better now. Okay, so what's the answer? So that's what we want to evaluate then. Remember, we this is square root, so we need to check all the exponents that are different. Yeah.
So, sir, the answer then would be then 2 to the power of 3, 3 to the power of 2, and 5 to the power of 1.
Should we clap for him? So remember that all of them they are multiplication, right? Okay. Let's try another example. I want to evaluate the cube root of 2 to the power of 3. No. Yeah. Can you give me the answer? Are you following? You sure? So what's the answer? They see some space over here. Yeah, there's some space over here. Yeah, another one. Yeah, another. Yeah. 2 to the power. Yeah. Good. All right. Perfect. Eh? Okay, good. Yeah, so you see now that it's easy. So you just need to apply the formula. Yeah? Have a question?
Yes, sir. So, sir, when we leave it like that, like 2 to the power 1.
Yeah, you can evaluate it. You can give the answer actually. So, 2 times 9 is what? 18, right? 2 times 9 is 18. 2 to the power 1 is what? 2. 3 square is what? 2 times 9 is what? So, that is the answer.
But, sir,
Yeah. And the same thing goes here too. But actually, if it is asked to leave it in the exponential form, you just leave it like that. Because what I'm trying to give is just the answer, the final answer. But if it is, write it in the exponential form, just leave it like that. Okay? Easier. You see that math is easier. Math is easier. Just for today. Other days, you come down. Okay. Yeah, this is okay. So now let's look at. I think we started with fraction last time. Okay, and we learned a bit of how to do product of a fraction, multiplication of a fraction, addition of a fraction. You should be able to, given a fraction, some fraction numbers, it's important for you to be able to know how to add them, how to multiply them, how to divide them, and how to do some basic operation. Okay? So actually we have a different type of fraction number. We have proper fraction, we have mixed fraction. Okay, all those they are in the notes, but let's look at few representation of fraction. But we know already that the fraction is a number that has a numerator and a denominator, and the denominator has to be different from 0. That's what we know. Who is that one? Who is it? Are you in the class? Are you from the class? What's the time now? You don't care, you come in class at any time. Huh? You're supposed to get know your building before, and then so that you won't get lost. Just go one time. Okay? So we have actually different representation of a fraction number. Okay? And we know that a fraction number has to be at the form A divided by B. Yeah? Okay, so we have what we call simple fraction. We have what we call a complex fraction. We have what we call proper fraction. But those are just words. Those are just terminology. If I say complex fraction, I give an example of simple fraction. This is called simple fraction. If I say 2 divided by 3, it's simple. A simple fraction. Okay? It's a complex fraction when I start to say like, okay, you see, this becomes a complex. Because now I say fraction with fraction. But if you see very well, my numerator is what? My numerator is the fraction. No. 1/3 is my numerator. And my denominator is what? 5, eh? Yeah. So my numerator is 1/3 and then my denominator is 5. So the numerator, if the numerator is another fraction, we call it a complex fraction. Or if the denominator is another fraction, we call it a complex fraction. Or if I say 1/3 divided by 2/7, this is another complex fraction. Okay? 2/5 divided by 7, this is complex fraction. And actually we understand how to do this kind of operation. It's called quotient, it's called division, and we know how to do division. Yeah? Okay? Complex, that's what we call complex fraction. An example of complex fraction, it would be 2 1/3 divided by 5. That's a complex fraction. What's going on here? If you have a question, you just raise your hand and speak. Otherwise, at the end, we'll discuss later. We can't have different voice going on. Okay, if you have a question, just let me know and then. So this is a complex fraction. You see now that this big here, this is what's the numerator? The numerator is this thing, and the denominator is this. That's why when you are writing the fraction, just make sure that you write that bar very well. Let it be bar so that you know you differentiate the numerator of the denominator. Okay? So here, what is our denominator? And what is our numerator? Yes, it has 1/3. Okay? And if I want to put the answer now, what is 2 times 1/3? Yeah? What is 2 times 1/3? 2 times 1/3. Yeah? 2 times 1/3. You said you are thinking. Yeah, sure. What is 2 times 1/3? You don't know. Oh. 2 times 1/3. What's going on here? So it should be 2/3 divided by,
It's 2/3.
and then what is the answer of 2/3 divided by 5? What is going on? What is it? Is it difficult? Okay. 2/3 divided by 5. What's the answer? This is
2/3 times 5/1.
no. What is the answer of this? We learn how to do a quotient. Yeah, we learn how to do a quotient. You remember? Remember last time? Were you here last time? Were you here last time? Oh, my goodness. What happened? Your intention. Are you still intentioning the group until now? You don't know your group until now. We are almost completing 1 month and then you're still intentioning. No. Okay. Yeah? 2/50. How do you do it? You say 2/50. It's true? It's true, huh? Huh? It's true? Yes, yes. I think we need to clap for how you could wonder how she did it. Huh? You can see her later after class. You can see her later after class. Okay, actually, we said last time that if you want to do a number like this, multiply by what? The inverse. If you want to do a division, you take the numerator and then you multiply by what? The inverse of the denominator. And what's the inverse of the denominator? B/C. What is the inverse of our denominator? What is our denominator? What's the denominator? The denominator is, what's our denominator? No. Look at this complex fraction. This is a complex fraction. Yes. Okay. And what is the inverse of our denominator? No? Huh? What is the inverse of 5?
1/5.
It's 1/5. How do you say 5? So multiply by 1/5. Because actually 5 is 5. You can write 5 like this. 5 divided by 1. So if you want to reflect it, it will be 1/5. Yeah? So then you just multiply now 2/3 multiplied by 1/5, which is 2 divided by, and that's what you get. Yeah. So if you are not consistent in the class, you will be lost because it's just a continuation of what we are doing. If you are not coming regularly, you are not following the recording session, whatever we are having, the strike and I don't know just all those things. You're not following, you'll be lost because it's just a continuation. It's continuation. Okay. So you will not gonna wait until the test. We announce the test. The test is 1 week now, and then you start now making your way to know everything at once. It won't work. It won't work. Yeah, it is actually a progress. You need to move alongside with what you are doing. If you wait until the date of the test, yeah, it will be releasing soon. It will be released soon. Yeah, soon. Maybe next week or yeah. Okay. You understand, eh? Okay. Okay, so you need to actually understand how to manipulate fraction. That's the chapter 2 already. We are already in the chapter 2. Yeah? We completed chapter 1 already. Yeah, we are already in chapter 2. Chapter 2 is common and decimal fraction. Common and decimal fraction. That's what we are dealing with now. Okay, so if I say I want to split pizza, for instance, I have 5 person and then I have 2 pizza. I want to split it to those 5 person equally. What should I do? Suppose that I have 2 big pizza. Pizza. What did you hear? What did you hear? And I have 5 persons around the table, and I want to split it equally. What should I do? What should I do? What should, We have five people around the table, and then we have 2 pizza, and we want to split the pizza equally. What should I do? 5. How much everyone will receive? I have. Oh, okay. I have 5 pizza. Anyway, there are 5 students. How should I divide equally? Huh? No, I said have 2 pizza. Yes, 2 big. And I have, yeah? Sorry? Cut both by. Yes. Okay, you cut that. That's very good. Starting point. Yeah, it's a real life situation. What who told you that it's supposed to be like it? That's just say it's actually it's what you are you know. It's what you know. But actually pizza is just let's suppose it's a pizza that has no fork. Yeah, it's not that. Yes, we want to cut it ourselves. Yeah, but yeah. Okay, so the question is that I have 2 pizza, okay, that have no fork. This you give it like that. And then you have 5 students around. And then you want to divide, split it in a way that you are all happy. And then you all have equal size. Okay? And then she started to say something. That's a good starting point. That I need to start dividing. Can you repeat what you say? What do you say? Cut both. So I first take 1, and then I cut it by 5. Yeah. So you need to find a way to cut it into 5. Yeah. Yeah. That's the first one. And the second one, I need to do the same thing. Like this, the same side, okay? So and then we solve the issue. So each student will take Each student will take 2 over 5. That's what I'm looking for. Each student will take 2 over 5. Yeah? Each student will take 2 over 5. Yeah? Well, we call it each of you guys will take 2 over 5. And you have a one. So you see now that fraction is actually a real life problem. Eh? Very nice. Okay. Yeah. Okay, so let's so and actually when I say 2 over 5 it's not the same as 5 over 2. Those are two different numbers. Okay? 2 over 5 and 3 over 5, two different numbers. Okay. So let's look at a way of simplifying a fraction. So because we saw how to do multiplication, how to do addition, how to do division. I think we saw those basic things. It should not be a problem for you anymore. Right? If you are struggling with adding fraction numbers and multiplying fraction numbers, dividing fraction numbers, subtracting, I think we need to work. So those are basic things. But now, when we have a fraction number, try to simplify. Okay, try to simplify. So there's a way of simplifying fraction number. Okay? Because simplification. So when you say simplify fraction number, it just means just reduce, write it in a compact form. Okay, so let's say I have 12 divided by 30, for instance. I want to simplify this fraction. What should I do? Mm-hmm. What should I do? Divide by 6. Both of them 6. And what should I get at the end? 2 over 5. 2 over 5. Okay. Yeah? It's clear? We divide by 4 or 5. 6. 30 divided by 6 is what? Okay. So you understand now how it works to divide a fraction, to simplify.
And you take the biggest number or the smallest?
No, there's no rule to take the biggest.
So I can just take any number that you know.
Not any number. A number, a divisor, the common divisor, both of them. A number that we divide both of them at the same time. If you take 5 there, if you take 7 will work. Because it takes 7, even if you take 5 won't work. Because if you take 12 divided by 5, it doesn't work. But if you take 30 divided by 5, it works. You need to take a number that both divide them at the same time. Okay? Yeah. So that's how you simplify numbers. So whatever the number that you have that is very complicated, bigger, you need to normally to simplify it. That's important. You need to simplify this number to have a very small fraction, compact fraction. And we got a reduced form. Okay? So if I give you 128 divided by 288, this you can simplify this one. Right? 128 what's the time now? We still have how many? 7 minutes. Where? You another word. We are finishing at 2:10 or 2:15. It's 2:15. We finished it. It's saying 7 minutes. Okay. So what we do with that one? 128, 288. What do we do? It's simple, eh? You just need to what? What do we do? Are you following? Yeah, yeah, okay. What do we do? Yeah, by what? Huh? Yes, divide by what? I need to divide by what? 4. Okay, start dividing by 4. What do we get? 128 divided by 4 is what? 32. Okay, so this is 32. And here, huh? Can we stop there? Can I stop there? What else? You divide by what? 8. 32 divided by 8, what is what? 12. And 70 divided by 8 is what? Oh, sorry. 32 divided by 8 is what? 4, okay. And 70 divided by 8 is what? 9. Should we stop there? Okay. So that's the simplified form, eh? You see? We can no longer simplify. We can no longer simplify. Yeah? Are you following at the back? Those who are you following? Is everything all right? Huh? Yeah? So, yeah. Okay. Now, yeah? You are laughing, eh? Everything is clear. When it's clear, when everything is clear, you laugh. When it's not clear, your face is so far. So everything is clear, eh? But now we want to compare. We want to start comparing numbers. We want to start comparing fractions. Remember that actually we saw that the set of real number is an order. It has an order. Is it for you? You can take it. Okay, so you can see two fractions and then be able to tell which one is smaller. If I give you two fractions, if I give you A over B and then I give you C over D, how will you know that A over B is smaller than C over D? That's what we need to see now. Because we have order. When we say order, we know that the set of rational numbers, it has an order. When I say order, it's an ordering set. It means that if you take two rational numbers, you can be able to compare them. That's what I mean by it's an ordering set. If you take two rational numbers, you will say that this is less than this, or this is equal to this, or this is greater than this. That's what we mean by order. Okay? So any rational number will be formed A over B, C over D. You need to compare them. You can compare them. How? That's what we need to see now. And after this, taking two rational numbers, if you will be able to compare them, that means that you are behind. Okay? That's the truth of matter. Okay, the lot of the truth. Okay, so let's take an example. If I take 2 over 3, and I say 2 over 1 over 3, that's a bit let's say not advanced, but in order for us to quickly understand where we are going, let's assume that we have common denominator. Okay, that will be easier for you to search to understand quickly. So if instead I have 2 over 3, no, let's say 2 over 5, and then I have 3 over 5. Okay? Yeah? So you want to compare a fraction that have common denominator. That's where you need to start. Whenever you want to compare a fraction, you need to make sure that they have a common denominator. And then you just compare the denominator. That's all. If you have a fraction and then they have different denominator, you need to find a way to bring them to have a common denominator, and then you just compare. So here now, both fractions they have a what? Common denominator, which is 5. And to compare them, you just compare the denominator, and the smallest is the one that have the smallest denominator, right? When they are positive, when they are positive. Okay, so here now it will be 2 over 3, 2 over 5 is less than. Yeah? Yeah? But it's because they have a common denominator. This is easier. Eh? This is. Sorry? Sorry? What? It's okay, it's fine? You already answered yourself. Okay. Alright. Okay, so now if you have 1 over 2 and then 1 over 3, what is the small? What should I put it here? What should I put it here? Huh? What should I put there? What? You can compare. I say every, if you take every 2 rational numbers is comparable. So you cannot tell me that you cannot compare them. Every. When you say every, it means that every 2 rational numbers you take is always comparable. Either is equal or less or superior. Okay? So it's maybe it's less, maybe it's equal, or maybe greater. We need to figure out it. And what should be there? 1 over 2, 1 over 3. It's bigger than 5. Because you use your calculator. And because it's straightforward. Okay. So this is what's bigger. Because this one is straightforward. But if I give a complicated number now, you start saying. Okay, so but now, how do you figure out it? How do you figure out it? So maybe you could try to write those numbers, put them in the common denominator. But that's you could do it quickly. If I want to put them in the common denominator, the 1 over 2 is actually I need to multiply by 3. We learned how to do it before, right? So it's actually 3 over 6. Yes? Yes. Right? Who is sleeping? Who is sleeping? Wake them up. Those who are sleeping. Okay? So that is true. Okay, now 1 over 3 is equal to what? 2 over 6. Yes, right? So we put them in the common denominator. Yeah? Who say yes? Who say yeah? Raise your hand. Yeah. Okay, so it's 2, you have 2 over 6 and 3 over 6. You see now they have common denominator. We just need to compare the denominator now. Which has the smallest denominator? It's 2, right? 2 is less than 3. So therefore we have actually 2 over 6 is less than what? 3 over 6. And actually 2 over 6 is what? 1 over 3. And less than what? 1 over 2. That's what we get. You see now? You see how we figure it? So when you are in a situation where you get numbers, fraction numbers that have different denominator, what you need to do is that you need to bring them to have a common denominator, and we learn how to, write simplify a fraction or convert a fraction to have a common denominator, and then when you see that they have a common denominator, now you can now compare them. Are we on the same page? Eh? Are you on the same page? Your question? On the same page? Or different page? Okay, so I think we need to continue. You want us to solve them? Yes. But look at the time. And we started 8. We started late. And also check the people that are entering late. They also absorb some time. So if I need to do the summation of all those times, we're supposed to finish at 2:30. No. Yes. That's the truth, eh? Because every time that someone enters, we stop and distract us. We lost 1 or 2 minutes. So just do the summation of all those at the end. We just added. Anyway, so it's not your time. Okay? It's not your time. Okay? But anyway, you have any question? Just ask question now. Question? Okay, there's no question. Then continue. Okay, she said she has a question. Okay, she said, let's compare a bit complicated example. Okay? Okay, let's try another example. Okay? Suppose that I want to compare okay, I want to compare those two numbers. But first of all, when you say compare, you should not look at those numbers and then say, since the denominator is greater than the numerator now, this one is bigger. That is not true. For fraction, it's not like that. When you say compare a two fractional numbers, you should be careful. This is not true. If you check the number, I see that the denominator is greater, then the number must be greater. That's what people usually do. I say, let's see, the denominator, they have a greater denominator, then I will just write. That's no. A completed no. And also, you see, they have, you see, the lesson, they have different numerator, and this is smaller than I should put no. Okay? Repeat what? I say that when you see you have a fraction number, you should not rush by just compare them, looking at just the denominator or looking at the numerator, because they have maybe one denominator is less than this, then you conclude that the fraction is less than the other. No, you should not do that. That's what I say. So actually, you should not be telling me that this number is greater than this. Maybe it could be, but you should not give me a reason, maybe an argument that because this is greater than this. Okay? Are you calculating? Using your phone? you that you're not supposed to be using phone in class? Yeah? Yeah, it's in class. Okay? You're not really supposed to be chatting. Okay, so what will you do in that situation? What will you do? We still have 5 minutes. We still have 5 minutes. What should I do? Yes. Yo. Yes, yo. Yeah? I'm talking to you. Yes. But while you are pointing to another, we have eye contact. You know what is called eye contact? My eye is not on you. What should I do? Huh? What is happening? You don't know. And you follow you. Okay. Yeah. You try to hide yourself. But it's like those who are the back are sleeping. Those who are the back are sleeping. They are sleeping. Huh? Are you sleeping? Okay. This is what. Yeah, you. What should I do? You see now what I'm saying?
Yes.
Those who are the back are sleeping. Can you disprove what I'm saying? Try to disprove what I'm saying. If you're not sleeping, okay, tell me. What should I do? Huh? Okay. You. You. What should I do? Okay, at least I know that those one are wicked. Those two are wicked. You. What should I do?
Yes, sir.
You are being awakened. Are you awake?
No, sir, I'm awake, sir.
You are awake or you are sleeping?
No, sir, you have to take to the